The manipulation of deformable linear objects is a prevalent yet challenging process in manufacturing. Existing studies addressed isolated sub-problems, but exploration in integrated assembly workflows is limited. Here, we introduce a holistic, object-centric framework for DLO assembly, including bin picking, handover, and mounting. In the bin picking stage, the DLO needs to be segmented and separated from a packed set. For segmentation, we leverage SAM2 to obtain the shape of the DLO and select a good grasping point from it. A state machine approach detects picking errors from force torque sensors. In the case of an error, it releases and tries again. The approach shows reliability in experiments with a success rate of 89.7%. In the handover, we correct the DLO's 3D shape obtained from vision with visual, tactile, and proprioceptive sensing. Such a correction achieves a more precise shape tracking, particularly during movement or under occlusions. It also reduces the grasping errors and thus increases the handover success rate to 81.25%. Finally, the whole framework is validated in a real-world, comprehensive assembly process, where multiple robots collaboratively pick a target DLO, transport it to the mounting workspace, and mount it on fixtures.